Alright, what I want to show you here is a two-body elastic collision. Sort of thing that happens with two billiard balls. We will represent the two balls, if you like, M1, M2. They could be different masses, then they wouldn't be billiard balls, would they? We have a V1 and we have a V2. So we're going to have a V1 initial and a V2 final. Now, because it's an elastic collision, we can say that kinetic energy before for the system equals kinetic energy after for the system. So that's M1 V1 initial squared plus 1/2 M2 V2 initial squared must be equal to 1/2 M1 V1 final squared plus 1/2 M2 V2 final squared. That's your kinetic energy formula. And if we simplify that down, we're going to be ending up with M1 times V1 initial squared minus V1 final squared must be equal to M2 times V2 final squared minus V2 initial squared. What have we basically said with that formula? We've said that the change in, well, not kinetic energy, but we're basically, this is kinetic energy, change in kinetic energy, we just cancelled out the 2's, is equal for M1, is equal to the change in kinetic energy for M2. And since they're adding together to give a constant, we would expect that. It's the same sort of thing we're going to get with conservation of momentum. So this was conservation of kinetic energy. Now we're going to look at conservation of momentum. Alright, so in that case we've got M1 V1 I plus M2 V2 I must be equal to M1 V1 final plus M2 V2 final, what we'd expect. That's going to give us an equation which basically says M1 times V1 initial minus V1 final is going to be equal to M2 V2 final minus V2 initial. That basically is saying that the change in momentum for block 1 or ball 1 is equal to the change in momentum for ball 2. And that's pretty much what we'd expect, because if you're going to have conservation of momentum, the change on one must be equal to the change on the other one. Now we can use a mathematical formula that we're well used to. A squared minus B squared is equal to A plus B times A minus B. Now if we go back to this part, we can see we've got an M1 times V1 initial squared minus V1 final squared. Same with this one. So we can rewrite those based on this formula. We can say, okay, so that's M1 times V1 initial minus V1 final times V1 initial plus V1 final. And we can also write, that's what that equals, and that's equal to M2 V2 final minus V2 initial V2 final plus V2 initial. Alright, so now we're looking good. We can now substitute in the M1 equal times M1 initial minus V2 final, and we can say that that is actually equal to this one here. So in substituting that one back in, M1 equals V1 final minus V1 initial, same thing as what we've got here. We can substitute that back in and say M2 V2 final minus V2 initial times V1 initial plus V1 final, and equals all that. Now these two guys are now the same. That one with that one. We can cancel them out. And we can end up with V1 initial plus V1 final equals V2 final plus V2 initial. Basically what we've ended up saying is that if we add up the velocities, V1 initial and V1 final, they're going to be equal to V2 final and V2 initial. Remember that this is only for an elastic collision with conservation of kinetic energy, and conservation of momentum is always there.